10,000 eyes are watching you from space, right now, at this very second. Most people have no idea that above their heads, invisible, silent, moving faster than a bullet, there is an army of machines circling the Earth. Not dozens, not hundreds, 10,000. And in a single night launch off the California coast, SpaceX just crossed a threshold that no company, no government, no civilization in human history has ever reached before. Here is the twist that will make your brain stutter for a moment. On the exact same night that SpaceX launched the rocket that pushed its Starlink constellation past 10,000 satellites simultaneously orbiting Earth, it was also the 100th anniversary of the very first liquid-propelled rocket ever fired into the sky. Robert Goddard, March 1926, a small rocket fueled by gasoline, rattling into a Massachusetts winter sky, traveling a few hundred feet before crashing into a cabbage field. 100 years later, to the day, a Falcon 9 rocket, the 615th flight of that model alone, lit up the Pacific darkness and carried 25 more satellites into the void. The distance between those two moments is the entire story of what human ambition looks like when it refuses to stop. Liftoff happened at 10:19 p.m. Pacific Time on March 17, 2026, from Space Launch Complex 4 East at Vandenberg Space Force Base in California. The rocket, Booster B1088, flying for its 14th time, arced southward over the ocean, climbing through darkness and thin air, burning kerosene-based propellant in controlled explosions that produce more power per second than most people can comprehend. A little over 8 minutes after leaving the ground, the booster separated, flipped itself around in vacuum, and descended through the atmosphere on a column of fire, landing on a drone ship named Of Course I Still Love You, floating in the Pacific. It was the 184th successful landing on that specific vessel, the 586th booster landing for SpaceX in total. These numbers have become so routine that they barely register anymore, and that normalcy is itself a kind of miracle. The 25 Starlink satellites separated from the upper stage roughly an hour after liftoff, drifting into their assigned orbits to join the constellation already humming in the sky. And with that quiet deployment, an invisible empire crossed into 5 digits. To understand what 10,000 satellites in simultaneous orbit actually means, you have to step back and think about the entire history of spaceflight. Humanity spent the first 60 years of the space age launching objects into orbit one by one, painstakingly, at enormous cost. By the early 2010s, the total number of active satellites from all nations combined hovered somewhere around 1,000. Then, SpaceX began. Its first batch of Starlink satellites launched in May 2019. Less than 7 years later, it has more active satellites in orbit than the rest of the world combined. And it is not slowing down. In 2026, SpaceX has been launching Starlink missions at an average pace of 1 every 2.3 days. 26 of its first 33 Falcon 9 launches this year carried Starlink payloads. The sky is not the limit, it is the workspace. The scale creates problems that have never existed before. 10,000 satellites in low Earth orbit means 10,000 objects moving at roughly 17,000 miles per hour in a region of space already cluttered with debris, dead satellites, and spent rocket stages. Every day, the Starlink constellation executes tens of thousands of avoidance maneuvers, automated, split-second decisions made by onboard computers to nudge each satellite slightly out of the path of potential collisions. Dr. Jonathan McDowell, an expert orbital tracker and X-ray astronomer, described this reality after SpaceX crossed 10,000 total launches last October. The number of avoidance maneuvers happening every year is so far beyond what anyone was doing even in the last decade, he said, that it represents a genuinely new category of space operations. Whatever your feelings about SpaceX, he added, this is a remarkable technical achievement. To manage it, SpaceX has built its own space situational awareness system called Stargaze. The system uses the multiple star trackers already mounted on each satellite, instruments originally designed to help orient the craft by reading star positions, and turns the entire constellation into a distributed telescope network that maps objects in low Earth orbit in real time. It is one of the more quietly astonishing pieces of engineering behind a program already full of them. The reasons SpaceX was able to get here when no one else could are worth understanding. Caleb Henry, director of research at Quilty Space, a firm that analyzes the satellite industry, has identified 5 major factors. The first is financial. SpaceX raised more private capital than any comparable constellation project in history, billions of dollars that gave it the runway to iterate, fail, and improve at a pace no government program or traditional aerospace company could match. But money alone, Henry is careful to say, is not the explanation. The deeper answer is vertical integration. SpaceX builds its own rockets, it builds its own satellites, it builds its own ground stations, and critically, it builds its own user terminals, the dish antennas that customers set up on their rooftops and boats and trucks to connect to the network. Starlink is manufacturing those terminals at a scale that is 1 to 2 orders of magnitude above any competitor. That volume drives down cost so dramatically that it has essentially created a new consumer market for satellite internet that did not previously exist. As of February 2026, Starlink reported more than 10 million active customers across 160 countries, territories, and markets. In the single month following that announcement, service was activated in Niue, Kuwait, and the Central African Republic. The constellation isn't just a product, it's becoming infrastructure, the kind of infrastructure that eventually stops feeling optional. And it is still growing. The next phase is already in motion. SpaceX is preparing to launch Starlink version 3 satellites using its Starship rocket, the largest launch vehicle ever built, still in active testing. Those version 3 satellites are expected to carry roughly 1 terabit of capacity each, dwarfing any other low Earth orbit satellite currently in service. Each one will be heavier and more capable than anything in the current constellation. Quilty Space forecasts as many as 8 Starship launches carrying Starlink payloads in 2026 alone. If even a fraction of that capacity reaches orbit, the network will become something qualitatively different from what exists today. Faster, broader, more resilient, and present in places that current internet infrastructure has never reached. 100 years ago, a rocket fell into a cabbage field in Massachusetts, and a man wrote in his notebook that the experiment had gone better than expected. Tonight, 10,000 descendants of that experiment are circling the planet, routing data through vacuum at the speed of light, connecting 10 million people in 160 countries to a network that did not exist 7 years ago. Here is the question worth sitting with. If this is what one company built in 7 years, what does the sky look like in another 7? And who decides, and how, what happens to the thin shell of space that wraps around the only planet we have? Leave your answer in the comments, because in the age of 10,000 satellites, the sky is no longer just above us. It belongs to whoever gets there first.